We've seen that if y can be written as a function of u and u as a function of x, then dy over dx is equal to dy over du times du over dx. However, sometimes a function can be expressed as a composition of three functions or even more. But let's look at the case where y is a function of u is a function of w, and w is a function of x. Then dy over dx is equal to dy over du, so that's the derivative of y with respect to u times the derivative of u with respect to w times the derivative of w with respect to x. And again, you can think of the dw's and the du's as canceling out, and that's going to simplify to just dy over dx. And this is why this rule is called the chain rule. If we have, say, a function y that is a composition of four functions, we can just throw on another one of these derivatives, and it's like these are the links in a chain, and we can add as many as we need. So let's look at a couple of functions that are the compositions of three functions. So here we've got y equals the fifth power of sine of 3x. So I'm going to start breaking this down into into a composition of functions. And I'm going to start with the innermost function. And that will be the 3x, and I'm going to call w, or I'm going to call 3xw. Now, is there a function of w? Is there a function of 3x? Well, I would say the outermost function is the fifth power, but in the middle there's this sine function. So I'm going to let u be the sine of w, and then y is u to the fifth. All right? So if we differentiate each of these, what we're going to get is the derivative of y with respect to u, which is 5u to the fourth. Differentiating this is going to give us the derivative of u with respect to w, and that is cosine of w. And then the derivative of this is going to be dw over dx, the derivative of w with respect to x, and that is 3. Alright, so the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to w times the derivative of w with respect to x. So that's going to be 5u to the fourth times cosine of w times 3, which would be 5 times, let's see, u is the sine of w, raise that to the fourth, but I'm going to replace the w with 3x, right? This would be the sine to the fourth of w, but I'm going to go ahead and write everything in terms of x, so w is 3x. Then we've got the cosine of w, and then we've got 3. I'm sorry, I left out, that should be 3x. And so we could go ahead and combine the 5 and the 3 and make that 5 times the sine to the fourth of 3x times the cosine of 3x. But again, I don't necessarily want to write all that out. So what I'm going to do is take a look at what's going on. This is the derivative of the outside function, this is the derivative of the middle function, and this is the derivative of the innermost function. So I'm going to look up here at this and just differentiate the outside function. Well, the outside function is something to the 5th power, so that's 5 times something to the 4th power. But now what goes in here? Well, we don't change what's inside right there. We don't change that until we don't change that at all. Now we need to multiply by the derivative of the middle function, the middle level function. Well, that would be the sine function. So we'll multiply that by the cosine. Cosine of what? Well, it was the sine of 3x. It's going to be the cosine of 3x. So you're only differentiating one function at a time. When I differentiated the something to the 5th power, I brought the 5 down and had something to the 4th. I did not differentiate this function. I left it alone. When I came down to the middle level function, I differentiated the cosine, but I left the 3x alone. Now it's the 3x's turn. We'll differentiate the innermost function, and that's 3. And that's the same thing we got up above. Let's try the second one and see how it goes. And I think I'm going to not bother writing all of this stuff out. I will say the outer function, I would call that the tangent. Well, I'll call it the tangent of u. And then the middle level function is the cosine of w, and then the innermost function is 2x. Alright, so f prime of x is the derivative of the outermost function. Well, the derivative of the tangent function is secant squared. Secant squared of what? Well, you don't differentiate anything else at this level. We differentiated the outermost function, the tangent. Everything else is left alone for now. So we leave the cosine of 2x as it was. Now we move on to the middle level function, the cosine. Well, the derivative of the cosine is negative sine. Negative sine of what? Well, we differentiated the cosine. We do not want to differentiate its inner function just yet. We'll leave that alone. And then finally, when we get to the outer function, that's when we differentiate that, and that'll be 2. So this would be minus 2, and I think I'll write that as sine 2x secant squared of cosine 2x.